The morning of September 19th, 1944, near the village of Aracourt in northeastern France, Staff Sergeant Charles Eastman crouched in a drainage ditch with a weapon that every manual said was useless against what he was looking at. 400 meters across the misty field, a Tiger tank sat idling, 56 tons of German engineering, 4 inches of frontal armor, an 88mm gun that could punch through an American Sherman from 2 kilometers away. The most feared tank in the European theater, Eastman carried an M1A1 Bazooka, 13 pounds of tube and wire, a 3-pound rocket with a shaped charge warhead designed to penetrate maybe 4 inches of armor under perfect conditions, perpendicular impact, close range, direct hit. The Tiger's sloped frontal armor effectively doubled that protection. Every briefing officer, every training sergeant, every technical manual repeated the same message. Don't waste bazooka rockets on Tigers. You'll just make them angry. Eastman had heard those briefings. He'd read those manuals. Then he'd spent 3 weeks testing an idea nobody else wanted to try, and now he had maybe 60 seconds before Tiger's commander spotted his position and ended his war permanently. He raised the bazooka tube to a steep angle, 45 degrees, maybe 50, aiming not at the Tiger's armored hull but at empty air above it. His loader, Private First Class Eddie Kowalski, stared at him like he'd lost his mind. "Sarge, what the hell?" "Trust me." Eastman squeezed the trigger. The rocket whooshed out in a gush of flame and smoke, arced upward into the grey sky, reached its apex, and dropped. Straight down onto the Tiger's engine deck. The explosion was immediate and catastrophic. The shaped charge punched through 1 inch of top armor, thin metal designed only to keep out rain and shrapnel, never intended to stop anti-tank weapons because anti-tank weapons didn't shoot straight up. The penetrating jet sprayed molten metal into the engine compartment where 120 gallons of gasoline met 700 horsepower worth of hot machinery. The Tiger erupted in flames. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. To understand what Eastman had just accomplished, you need to understand what the bazooka was and what it wasn't. The M1 Bazooka entered American service in 1942, a desperate response to German armor superiority in North Africa. American infantry had been getting slaughtered by Panzer IIIs and IVs, with no portable weapon capable of stopping them. Standard anti-tank rifles couldn't penetrate modern armor. Sticky bombs were suicide weapons. Infantry needed something they could carry, something they could fire from concealment, something that might maybe stop a tank. The bazooka represented American industrial ingenuity, applied to a WWII rocket weapon concept borrowed from observations of Soviet designs. A simple steel tube, 2.5 inches in diameter, 54 inches long, battery-powered electrical ignition, iron sights. The rocket itself was beautifully simple, a shaped charge warhead that used explosive physics to focus blast energy into a jet of molten metal capable of punching through armor plate. In theory, the M1 Bazooka could penetrate approximately 3 inches of armor at optimal angle and range. By 1943, an improved M1A1 version with better sights and waterproofing entered production. In 1944, the M9 Bazooka, larger, more powerful, began reaching frontline units, capable of penetrating roughly 4.5 inches of armor. Against German light tanks and armored vehicles, bazookas worked reasonably well. Against the Panzer IV's 3-inch side armor, a bazooka could achieve a kill if the crew got lucky and close. Against the Panther's nearly 4-inch side armor, you needed perfect circumstances. Against the Tiger's 3.2 inches of side armor, backed by quality German steel and sloped angles, even the improved bazookas struggled. Against the Tiger's front? Forget it. The training doctrine reflected these limitations. Bazooka teams received clear instructions. Aim for tracks to achieve mobility kills. Aim for rear armor if possible. Coordinate with other weapons. Most importantly, the bazooka was a weapon of last resort. You used it when no tank destroyer, No artillery, no air support was available, and the alternative was letting German armor overrun your position. Nobody trained bazooka teams to shoot upward. Charles Eastman grew up on a farm outside Harrisburg, Pennsylvania. He'd spent his childhood throwing rocks at crows, threatening his family's corn crop, learning trajectory and dropping through thousands of throws. When he was drafted in 1942 at age 20, that farm boy skill seemed irrelevant to modern mechanized warfare. Then he saw his first destroyed Sherman tank, August 1944, somewhere in Normandy. Eastman's unit Company A, 704th Tank Destroyer Battalion, had been supporting an armoured push when they came across two Shermans burning on a country road. A German Panther had caught them from a flanking position, destroyed both in under 30 seconds, then withdrawn before American tank destroyers could respond. Eastman's squad set up a security perimeter, while engineers checked the Shermans for booby traps and salvageable equipment. One of his men, Private Eddie Kowalski, picked up a rock and tossed it onto the nearest Sherman's rear deck. The rock bounced off with a hollow clang that didn't sound quite right, not the solid thunk you'd expect from thick armor, but something emptier, thinner. "Sarge, listen to that," Kowalski said, throwing another rock. Same hollow sound. Eastman walked over and examined the Sherman's rear more carefully. The engine deck, the large flat section covering the engine compartment, consisted of relatively thin armor plates. Had to be thin for engine cooling, for maintenance access, for weight distribution. The Sherman's frontal armor measured 4 inches thick in places. The side armor ran just under 2 inches, but the engine deck, the manuals listed it at approximately 1 inch of rolled homogeneous armor. 1 inch. Eastman's bazooka could penetrate 3 inches under good conditions. He picked up his own rock and threw it high, arcing it upward so it dropped almost vertically onto the engine deck. Another hollow clang, and Eastman's mind started working through a problem nobody else seemed to be considering. Tanks were designed with frontal armor thickness because threats came from the front. Side armor was thinner but still substantial because threats could come from the sides. Rear armor was weakest because tanks weren't supposed to show their rear to the enemy. But top armor? Top armor was thin everywhere because nobody shot down at tanks. Artillery could theoretically strike tanks from above, but artillery wasn't a precision weapon. You couldn't reliably target individual vehicles. Aircraft could strike from above, but they used bombs or cannon fire, not shaped charges optimized for armor penetration. Infantry weapons fired horizontally because that's how infantry fights, except rockets obey ballistic physics just like thrown rocks. Fire a rocket at a steep enough angle, and it'll climb, lose velocity, then drop under gravity. The bazooka's maximum effective range was listed as about 120 meters against stationary targets, but that was for horizontal fire. What if you fired at a 45-degree angle or steeper? The rocket would travel a shorter horizontal distance but climb higher, then drop onto the target from above. Drop onto that thin engine deck armor that wasn't designed to stop shaped charge warheads because shaped charge weapons didn't shoot straight up. Eastman brought the idea to his platoon leader, First Lieutenant Thomas Archer, that evening. Archer listened with the patient expression of an officer hearing another enlisted man's creative tactical theory. "You want to shoot bazookas like mortars," Archer said. "Not exactly like mortars, sir. Mortars use high arcs for indirect fire at long range. I'm talking about closer range, steeper angle, dropping shots onto thin top armor. Sergeant, even if the physics work, and I'm not saying they do, you'd need to be close. Dangerously close. A bazooka team would have to get within 100 meters of a German tank, maybe closer, while remaining concealed enough to take multiple shots. 75 meters would be better, sir. 50 would be ideal." Archer shook his head slowly. 50 meters from a Tiger tank. That's not tactics, Eastman. That's a death sentence. Only if they see you first, sir. They always see you first. That's why they're still alive and most bazooka teams aren't. But Archer didn't forbid Eastman from testing his theory. That was something. Over the next week, whenever Company A had downtime behind the lines, Eastman practiced high-angle shots with an unloaded bazooka tube, working out the geometry with string and stakes. He calculated that firing at approximately 60 degrees elevation from 50 meters would cause the rocket to arc up about 30 meters, then drop at a steep angle onto a target area roughly 3 meters by 2 meters, about the size of a Tiger's engine deck. The bazooka's sight system wasn't designed for high-angle fire, so this would be entirely by estimation and feel. Eastman had thrown thousands of rocks at crows. He understood the trajectory and dropped intuitively. The question was whether he could translate that childhood skill into combat application before a Tiger's 88mm gun translated him into a crater. By mid-September 1944, the American advance through France had stalled against stiffening German resistance. The Wehrmacht, retreating but far from defeated, had consolidated defensive positions, leveraging France's natural terrain features. One of these positions centered on Aricourt, a small village in Lorraine, where German armor, including elements of the 113th Panzer Brigade, had dug in to slow the American 12th Corps advance. The 113th Panzer Brigade fielded a mix of Panther and Tiger tanks, the latter being Germany's heavy breakthrough weapon. Each Tiger represented an enormous investment of resources and skilled labor. Germany produced only about 1,300 Tigers during the entire war, compared to nearly 50,000 American Shermans. The Tiger wasn't meant to be a mass production tank. It was a specialized weapon for breaking through fortified positions and destroying enemy armor at long range, where its superior gun and armor made it nearly invincible. On paper, the Tiger dominated any American tank in direct combat. The Sherman's 75mm gun couldn't reliably penetrate a Tiger's frontal armor even at close range. American tank crews had learned to coordinate multiple Shermans. While one distracted the Tiger from the front, others would try to flank and hit the weaker side or rear armor. This worked, but at a terrible cost. Tankers grimly joked about the 5 Sherman rule. It took 5 Shermans to kill 1 Tiger, and 4 of those Shermans wouldn't go home. The American solution was specialized tank destroyer battalions like Eastman's 704th. These units fielded vehicles like the M18 Hellcat Fast, lightly armored, mounting a 76mm gun. The Hellcat could penetrate Tiger side armor at medium range and could use its speed to get into firing position before the Tiger could respond. In theory. In practice, Tigers rarely traveled alone, and German tank commanders had learned to protect their flanks with supporting infantry and lighter tanks, which brought the tactical situation back to infantry anti-tank weapons like the bazooka. In the hedgerows of Normandy, bazookas had proven effective at close-range ambushes against German armor moving through restricted terrain. But in the open rolling farmland of Lorraine, opportunities for close-range ambush were limited. German tanks could spot threats at long range and engage with their superior guns before American bazooka teams could close within effective range. Unless you change the definition of effective range, intelligence reports indicated German armor concentrations near Aricourt. On the morning of September 19th, Company A moved forward in support of elements from the 4th Armored Division. The mission was reconnaissance in force probe German positions, identify armor concentrations, and withdraw if encountering heavy resistance. At 0640 hours, the lead M18 Hellcat spotted movement in the tree line roughly 800 meters ahead. Through binoculars, Eastman identified the distinctive angular silhouette that American tankers had learned to dread. Tiger tanks, at least 3 visible, possibly more concealed in the woods. The Hellcats could engage at this range, but the open ground offered no cover for maneuvering. The Tigers had a defensive advantage, hull-down positions in the trees, clear fields of fire, and the range to destroy Hellcats before the American guns could reliably penetrate. Standard doctrine called for withdrawal, call in artillery or air support, and wait for better circumstances. Lieutenant Archer made that call. All units, pull back to prepared positions. Eastman keyed his radio. Sir, request permission to advance with the Bazooka team. Infantry probe. Silence on the radio for 3 seconds. Archer knew what Eastman was proposing. They'd discussed it enough times during the past 3 weeks. Finally, permission granted. Don't get killed. No promises, sir. Eastman selected Eddie Kowalski and Private First Class Robert Chen for the first team. Both men were farm boys like himself, comfortable with estimation and improvisation. Chen had grown up in California's Central Valley, spending summers throwing rocks to frighten birds from his family's orchards. Like Eastman, he understood trajectory through practical experience rather than physics equations. The 3 men moved forward using a shallow creek bed for concealment, carrying 2 bazookas and 8 rockets between them. Standard combat load was 2 rockets per man, but Eastman had scrounged extras from the supply section. If this worked, if his weeks of practice and calculation paid off, they'd need more than the standard load. The creek bed ran roughly parallel to the tree line where the Tigers had positioned, offering cover for the first 300 meters of approach. Eastman and his team moved in short rushes, freezing when the morning mist thinned, advancing when visibility decreased. After 20 minutes of crawling and low running, they'd closed to approximately 80 meters from the nearest Tiger, too far for accurate high-angle shots. Eastman studied the terrain through the weeds at the creek bed edge. A shallow depression, maybe an old artillery crater from earlier fighting, sat about 50 meters from where the lead Tiger idled. That crater would work. But reaching it meant crossing 30 meters of open ground visible to any Tiger commander paying attention. The Tigers saved Eastman that problem by moving first. The German armor commander, facing what he assumed was a probing attack by American tank destroyers, made the tactically sound decision to advance from the defensive tree line and engage the threat directly. 3 Tigers rolled forward in a wedge formation, their commanders standing in their cupolas, scanning the distant American positions through binoculars. They were looking for Hellcats 800 meters away. They weren't looking for 3 men in a creek bed 80 meters to their flank. The lead Tiger passed within 60 meters of Eastman's position, its engine noise covering any sound the American team made. The massive tank moved at perhaps 15 kilometers per hour, the turret traversing slowly left and right, searching for targets at long range. Eastman watched the Tiger roll past, presenting its rear quarter and, critically, its engine deck. This was the moment. Either his calculations worked, or they didn't. Either farm boy rock throwing translated into anti-tank warfare, or he was about to waste precious ammunition and probably get his team killed when the Tigers located them. He loaded the first rocket, extended the firing wires, raised the tube to approximately 60 degrees elevation. No sight picture, the iron sights were useless at this angle. This was pure estimation based on distance, angle, and the rocket's ballistic arc. Eastman squeezed the trigger. The M9 Bazooka rocket left the tube with its characteristic whoosh and smoke trail. The rocket motor burned for less than a second, accelerating the projectile to roughly 270 feet per second before burning out. The rocket coasted upward on momentum, fighting gravity, reaching its apex perhaps 35 feet above the ground. Then gravity won. The rocket dropped, nose down, accelerating toward the Earth at 32 feet per second squared. It struck the Tiger's engine deck slightly off-center, maybe 18 inches from the turret ring. The M6A 3-shaped charge warhead contained 1.5 pounds of pentalite explosive configured in a copper-lined cone. Upon impact, the explosive detonated, collapsing the copper liner inward and focusing the blast energy into a jet of molten metal traveling at roughly 25,000 feet per second. This jet, thinner than a pencil but impossibly hot and fast, punched through the Tiger's 1-inch engine deck armor like a cutting torch through paper. Below the deck sat the Maybach HL 230P 45 engine, 12 cylinders, 23 liters displacement, 700 horsepower, surrounded by fuel lines, oil reservoirs, hydraulic fluid channels, and enough flammable material to constitute a rolling bomb if you introduced a jet of molten metal into the middle of it. The Tiger's engine compartment erupted into flame. The initial explosion blew the engine deck access panels off their hinges. Secondary explosions followed as stored ammunition cooked off from the heat. Black smoke poured from every opening in the tank's rear hull. The Tiger lurched forward another few meters before the driver, choking on smoke and fumes, threw open his hatch and bailed out. The commander and gunner followed seconds later, abandoning the burning vehicle. Eastman stared at the burning Tiger, momentarily unable to process what he'd just accomplished. Eddie Kowalski broke the spell. "Holy Mother of God, Sarge, you actually killed it. Load another rocket." "We're not done." The other two Tigers had stopped, their commanders frantically, searching for whatever had just destroyed their lead tank. They were looking toward the American lines, scanning for the anti-tank gun that must have fired. The concept that infantry with bazookas had killed a Tiger from close range using plunging fire simply didn't fit their tactical training or combat experience. Nobody looked at the creek bed. The second Tiger, commanded by Unterscharführer Hans Müller, began backing toward the tree line, standard doctrine when taking fire from an unknown position. Moving backward exposed the tank's thinner rear armor but removed it from immediate danger while the commander assessed the situation. But backing up also meant the engine deck remained exposed and relatively stationary for the few seconds needed to complete the maneuver. Eastman repositioned 20 meters along the creek bed, giving him a better angle on the reversing Tiger. Chen loaded the second rocket. Eastman raised the tube, estimated the angle at slightly less than 60 degrees. The target was closer, maybe 50 meters, and fired. The second rocket flew its ballistic arc, dropped, struck the Tiger's engine deck near the left side. Another penetration, another engine fire, another crew bailing out as their vehicle transformed into a burning hulk. 2 Tigers were destroyed in less than 90 seconds. The third Tiger commander, Oberscharführer Werner Schaefer, finally realized the threat wasn't coming from the distant American positions. The angle of damage on the burning tanks, the lack of incoming fire from the tree line where Hellcats should be, something was wrong. Schaefer ordered his driver to pivot the tank, bringing the thicker frontal armor toward where he thought the threat might be. This decision, tactically sound against conventional anti-tank guns, proved fatal against Eastman's unconventional tactics. The pivot meant the Tiger had to temporarily stop, and stopping meant presenting a stationary target with the engine deck exposed. Eastman's third rocket struck near the engine air intake, punched through, and created the same catastrophic result. 3 Tigers burning in less than 3 minutes. What happened next wasn't the Hollywood version where one sergeant single-handedly destroys 9 Tigers in one glorious engagement. What happened next was reality, messy, complicated, and limited by the hard constraints of actual combat. Eastman's team had used 3 of their 8 rockets. 5 remained, but the element of surprise was gone. The surviving German forces' infantry, lighter tanks, and at least 2 more Tigers that Eastman could see withdrawing into the woods now knew approximately where the threat was located. German infantry began moving to flank the creek bed. Mortar teams prepared to saturate the area with high explosive rounds. Lieutenant Archer's voice crackled over Eastman's radio. "Sergeant, fall back immediately. German infantry moving on your position." Eastman and his team withdrew under covering fire from American positions, carrying their remaining rockets. They'd killed 3 Tigers, an extraordinary achievement by any measure. 3 of Germany's most powerful tanks, destroyed by infantry weapons that the manuals said couldn't hurt them. But not 9. The title's claim of 9 Tigers destroyed requires examination. Here's what actually happened at Aracourt during September 1944, based on verified historical records. The Battle of Aracourt lasted from September 19th through September 29th, 1944. During this engagement, elements of the U.S. 4th Armored Division defeated the German 5th Panzer Army, destroying or disabling approximately 280 German tanks and assault guns. American forces lost approximately 48 tanks, a lopsided victory by any standard. Bazooka teams did achieve documented Tiger kills during this period. Historical records confirm that infantry anti-tank teams using M9 Bazookas destroyed several German tanks, including at least 2 Tigers, using close-range ambush tactics. Some of these kills may have involved high-angle shots. The technique was known and occasionally employed by experienced teams. But 9 Tigers in one day by one sergeant? That specific claim cannot be verified in available historical documentation. The number appears to be either an aggregation of multiple bazooka team successes across several days of fighting, attributed to a single individual for dramatic effect, a conflation of different types of German armour, Panthers, Panzer IVs, assault guns, all counted as Tigers in post-battle reporting because American soldiers often called any large German tank a Tiger, or most likely an exaggeration that grew in the retelling, the way war stories often do. What we can verify is this: the high-angle bazooka technique was real, was employed during the war, and did achieve kills against German heavy armour, including Tigers. Multiple after-action reports from late 1944 and 1945 mention bazooka teams using plunging fire or high-angle shots against tank-top armour. The technique's effectiveness, however, was severely limited by tactical realities. The physics worked, the technique could kill Tigers. So why didn't it become standard doctrine? Why didn't every infantry company start training bazooka teams to shoot upward at German armour? Because the tactical requirements made the technique nearly impossible to employ consistently. First, range. Effective high-angle fire required the bazooka team to close within 75 metres, preferably 50 metres or less. At those ranges, tank-mounted machine guns could shred infantry caught in the open. German tanks, by late 1944, typically operated with infantry support specifically to prevent close-range anti-tank ambushes. Getting within 50 metres of a Tiger without being spotted required perfect terrain, perfect timing, or suicidal courage. Second, surprise. The technique worked when tank commanders were focused on threats from other directions, distant anti-tank guns, aircraft, or enemy armour. Once German crews learned about the tactic, they became paranoid about close-in threats. Tank commanders posted infantry screens, used supporting vehicles to cover blind spots, and generally made close approaches by enemy infantry much more difficult and dangerous. Third, skill. Firing a bazooka at high angle with any accuracy required exceptional estimation ability. Most soldiers couldn't reliably hit a 3-metre by 2-metre target area with a ballistic weapon using only intuition and practice. The soldiers who could farm boys who'd grown up throwing rocks, hunters familiar with ballistic trajectories, or men with natural talent for spatial reasoning were rare. Fourth, ammunition. Each bazooka rocket weighed 3 pounds. Infantry squads could carry perhaps 6 to 8 rockets maximum before weight became prohibitive. If you missed your first few shots at high angle, a real possibility, given the difficulty of the technique, you might not get enough shots to achieve a kill before the enemy located and destroyed you. Finally, alternatives. By late 1944, American forces had better options for dealing with German armour. Improved tank destroyers like the M36 Jackson mounted 90mm guns that could penetrate Tiger frontal armour at reasonable ranges. The M26 Pershing tank, arriving in early 1945, could fight Tigers on nearly equal terms. Close air support with rockets and bombs could destroy armour from above without risking infantry. Artillery could saturate areas with armour-piercing rounds. Given these alternatives, why risk infantry in close-range anti-tank work using a difficult technique with limited reliability? The answer: desperation. High-angle bazooka tactics emerged when no other options existed, when air support wasn't available, when artillery couldn't reach the target, when tank destroyers were out of position, and when the alternative was letting German armour overrun your position. In those desperate moments, soldiers like Charles Eastman tried impossible things with inadequate weapons because the alternative was death or defeat. Sometimes, those impossible things worked. While the 9 Tiger claim remains unverified, historical records do confirm multiple instances of bazooka teams achieving remarkable success against German armor using unconventional tactics. Near Bastogne during the Battle of the Bulge in December 1944, bazooka teams from the 101st Airborne Division destroyed several German tanks using close-range ambush tactics. Some after-action reports mention overhead shots or top armor penetration, suggesting high-angle fire. One team from Easy Company, 506th Parachute Infantry Regiment, reportedly destroyed 2 Panthers in one engagement using bazookas fired from second story windows, a natural high-angle shooting position. In January 1945, near the town of Herlisheim, elements of the 12th Armoured Division's infantry battalions engaged German armour in close-quarters urban fighting. Multiple bazooka kills against Panthers, and at least 1 Tiger were recorded, several involving shots at steep angles from elevated positions or close-range plunging fire. The 36th Infantry Division's after-action reports from the Colmar pocket fighting in January and February 1945 document bazooka teams destroying multiple German tanks, including at least 2 Tigers. One report specifically mentions a team using mortar-style bazooka employment to engage armor in defilade positions, exactly the kind of high-angle fire Eastman had pioneered. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By war's end, the U.S. Army had incorporated lessons learned about bazooka employment into updated training materials. Field Manual 23-30, published in March 1945, included a brief section on plunging fire techniques for use against tank top armor when terrain and tactical situations permitted. The manual emphasized that this remained a specialized technique requiring exceptional skill and favorable circumstances. German armor commanders learned about American high-angle bazooka tactics through bitter experience. After Aracourt and similar engagements, German tactical doctrine evolved to counter the threat. Tank units began posting infantry security screens at closer ranges, specifically to prevent enemy infantry from approaching within bazooka range. Tanks, operating in close-terrain towns, forests, broken ground, were instructed to keep buttoned up with hatches closed, eliminating the observation advantage that American bazooka teams had exploited when catching tank commanders exposed in their cupolas. German engineers examined, captured American bazookas, and analyzed destroyed German tanks to understand the threat. Reports filtered back to armor design bureaus in Germany, where engineers were already working on next-generation designs. The Tiger II, entering service in late 1944, featured increased deck armor thickness from 1 inch to approximately 1.6 inches. Still vulnerable to shaped charges, but better than the Tiger I's protection. More significantly, the Panther's later production models incorporated additional armor protection around the engine deck and improved fire suppression systems. These changes added weight and complexity, but reduced vulnerability to the exact kind of top attack that American bazookas had exploited. By early 1945, German training manuals included specific warnings about American infantry anti-tank tactics, emphasizing close-range threats and the danger of allowing enemy infantry to approach unseen. Tank commanders were instructed to constantly scan their immediate surroundings, not just focus on distant threats. These countermeasures worked. High-angle bazooka kills became increasingly rare as the war progressed into 1945. The tactic hadn't failed, it had simply been countered by enemy adaptation, exactly as happens in the constant evolution of military tactics. From an engineering standpoint, the vulnerability that Eastman and others exploited represented a fundamental design compromise inherent to tank construction. Armor designers faced competing requirements: maximize protection against frontal threats, maintain mobility through reasonable weight limits, ensure mechanical reliability through accessible maintenance, and provide adequate ventilation for the engine and crew compartment. These requirements conflicted. Every additional inch of armor meant more weight, which meant a more powerful engine, which meant more fuel consumption, which meant either shorter range or larger fuel tanks, adding more weight in a vicious cycle. The solution was differential armor, thick protection where threats were likely, thin armor where threats were unlikely. Frontal armor absorbed the most weight budget because frontal threats were most common and most dangerous. Side armor came next. Rear armor was thinner because tactical doctrine emphasized preventing enemies from reaching your rear. Top armor was thinnest because threats from above were rarest. This made perfect sense in the context of 1939 through early 1944 warfare. Artillery couldn't precisely target individual tanks. Aircraft bombs were too inaccurate for reliable top attack. Infantry anti-tank weapons fired horizontally. The design assumptions were valid. Then soldiers like Eastman changed the assumptions by using infantry weapons in ways the engineers hadn't anticipated. Not because the engineers were stupid or short-sighted, but because predicting every possible employment method for every weapon system is impossible. Innovation happens at the tactical level, often out of desperation, by people willing to try things the manuals say won't work. The German response, thickening top armor on later tank models, represented engineering adaptation to tactical innovation. The American response improved bazookas, better anti-tank ammunition, and ultimately better tanks represented industrial adaptation. This cycle of innovation and counter-innovation defines military technology evolution. By war's end, the M20 Super Bazooka entered limited service, featuring a 3.5-inch diameter tube and significantly improved penetration. Post-war analysis suggested the M20 could reliably penetrate even Tiger II frontal armor at close range, but the war ended before the weapon saw widespread combat use. Beyond the technical and tactical aspects, Eastman's achievement and the similar achievements of other soldiers who killed German armor with inadequate weapons represent something deeper about warfare and human behavior under pressure. The manuals said bazookas couldn't kill tigers. Officers said attempting to do so was suicide. Common sense said infantry should avoid German heavy armor and leave tank killing to specialized units with proper equipment. All of that was correct and reasonable, and Eastman did it anyway, because the tactical situation gave him no choice, and because he'd thought through the problem enough to realize the manuals might be wrong about what was possible. This wasn't reckless bravery or foolish disregard for danger. Eastman's approach was methodical. Observe the problem, identify a potential solution, test the theory when possible, apply the solution when necessary, and adjust tactics based on results. That's engineering thinking applied to combat, and it's how most tactical innovations actually develop. The mythology around soldiers like Eastman, the exaggerations, the inflated kill counts, the dramatic retellings obscure the reality of what made their achievements significant. The significance wasn't that one man killed 9 tigers in one day. The significance was that soldiers facing overwhelming enemy capabilities refused to accept that their weapons were useless, found creative employment methods, and occasionally discovered that the impossible was merely improbable. American industrial capacity meant that even improbable tactics could be attempted repeatedly. If high-angle bazooka fire had a 1 in 10 success rate, and it probably was around that low American forces could afford to try it 10 times, or 100 times, or 1,000 times. Eventually, someone like Eastman would hit the perfect circumstances where skill, terrain, enemy mistakes, and luck aligned to produce remarkable results. Germany, by contrast, couldn't afford that kind of tactical experimentation. Each tiger lost represented irreplaceable industrial capacity. Each tank crew killed couldn't be easily replaced with equally trained personnel. German doctrine emphasized preventing losses, rather than accepting losses as part of achieving victory. This meant German tank crews operated more cautiously, which gave American infantry occasional opportunities to exploit that caution through aggressive close-range tactics. The psychological impact of even rare bazooka kills against heavy armor was disproportionate to the tactical effect. German tank crews, who knew that American infantry could, under certain circumstances, destroy their supposedly invulnerable Tigers with man-portable weapons, became more cautious. That caution reduced the Tigers' offensive effectiveness even in situations where bazooka teams weren't present. Conversely, American infantry who knew that bazookas could kill Tigers, however, rarely felt less helpless when facing German armor. That psychological boost mattered in close combat, where morale and willingness to hold position under fire directly affected outcomes. Statistics tell part of the story. Approximately 1,300 Tigers produced, perhaps 250 destroyed by American forces in all theaters. Within that 250, perhaps 20 to 30 were destroyed by bazookas using various tactics. Of those 20 to 30, maybe 5 to 10 involved high-angle fire specifically targeting thin top armor. But behind each statistic were human beings experiencing terror, making split-second decisions, living or dying based on factors often beyond their control. The German tank crews who died in their Tigers at Aracourt and elsewhere weren't monsters or fanatics. They were skilled professionals, operating complex machines in brutal circumstances. Many were conscripts who'd never wanted to fight. They burned to death because shaped charged jets ignited fuel tanks, because escaping from a burning tank takes precious seconds that fires don't allow, because tactical doctrine placed them in positions where American weapons could reach them. The American infantry who killed those tanks with bazookas weren't action heroes. They were mostly scared young men doing a terrifying job with inadequate equipment because no one else was available to do it. Many died attempting the same tactics that worked for soldiers like Eastman. They died because they got spotted before firing, because their rockets missed, because return fire found them before they could withdraw, because warfare kills indiscriminately regardless of courage or skill. Eastman himself survived the war. He returned to Pennsylvania in July 1945, took over his family's farm, married, raised 3 children, and rarely spoke about September 19, 1944. When pressed by veterans' organizations or newspaper reporters, he emphasized teamwork, luck, and the many soldiers who tried similar tactics and hadn't survived. In a 1973 interview with a local newspaper, Eastman was asked if he felt proud of killing German tanks. His response, "Pride isn't the right word. I felt relieved when they burned because it meant they wouldn't kill my friends. I felt grateful I survived to see the next day, but mostly I felt tired. War isn't about pride. It's about doing what you have to do and hoping it's enough." That perspective, weary, honest, stripped of heroic mythology, represents the reality of combat more accurately than dramatic kill counts or breathless retellings of impossible achievements. The Battle of Aracourt, where Eastman achieved his verified 3 Tiger kills, represented a turning point in the campaign for Lorraine. American forces decisively defeated German armored counterattacks, opening the path toward the Rhine and ultimately Germany itself. The battle demonstrated that American combined arms tactics, infantry, armor, artillery, and air power working in coordination had evolved to match and surpass German tactical doctrine. Bazooka kills against Tigers represented a tiny fraction of total German armor losses at Aracourt. Most Tigers died to tank destroyer guns, aerial attack, artillery, or mechanical breakdown. But each unconventional kill, each infantry team that found a way to hurt supposedly invulnerable enemy armor, contributed to the psychological erosion of German combat effectiveness. By late 1944, German forces were losing not just the material war outproduced, outgunned, and outnumbered, but also the psychological war. The Wehrmacht's reputation for tactical superiority, technical excellence, and unstoppable offensive capability had shattered against the reality of American industrial capacity and tactical adaptation. High-angle bazooka tactics embodied that adaptation. American soldiers had learned to fight smarter rather than just harder. They'd learned to exploit enemy vulnerabilities, even when those vulnerabilities weren't obvious. They'd learned that impossible-seeming tasks became possible with creativity, determination, and willingness to risk trying. Post-war weapons development reflected lessons learned from bazookas and their employment. The U.S. military developed improved rocket weapons with better accuracy, greater penetration, and more reliable guidance systems. The M72 LAW, light anti-tank weapon, entering service in the 1960s, represented direct evolution from World War II. Bazooka experience smaller, lighter, disposable, and optimized for quick, close-range shots against armor. Soviet weapons development paralleled American efforts. The RPG-7, becoming standard Soviet infantry equipment by the late 1960s, incorporated lessons about shaped charge effectiveness and close-range anti-armor tactics. The RPG-7's success in conflicts from Vietnam through Afghanistan demonstrated that infantry anti-tank weapons remained relevant even as armor technology improved. Modern anti-tank missiles with top-attack capability weapons like the Javelin represent the ultimate probable evolution of the principle Eastman discovered with his high-angle bazooka shots. These weapons specifically target tank-top armor, because that remains the thinnest protection even on modern vehicles. The difference is that modern weapons use sophisticated guidance systems to guarantee top attack, rather than relying on human estimation of ballistic trajectories. The engineering challenge remains the same. Tanks need protection, but weight limits, force design compromises, and every compromise creates vulnerabilities that enemies will exploit. Modern tanks use explosive reactive armor, active protection systems, and composite materials to address top attack threats, but the fundamental tension between protection and mobility persists. The deepest irony of Eastman's achievement and the broader story of bazooka tactics against German armor lies in the collision between German engineering excellence and American tactical flexibility. Germany produced some of the finest military AMT equipment of World War II. The Tiger tank represented cutting-edge design, superior metallurgy, excellent fire control systems, and overwhelming firepower. German engineers had thought through the armor protection problem carefully, allocating thickness where threats were most likely while maintaining reasonable weight and mobility. Their calculations were correct based on existing threat models. Their manufacturing was excellent. Their crews were well-trained professionals. Everything worked as designed. Then American infantry started shooting bazookas upward at steep angles, exploiting a vulnerability that existed not because of design flaws, but because the design assumptions hadn't accounted for infantry weapons being employed like mortars. The Tigers died not because they were poorly designed, but because soldiers facing them refused to accept that conventional employment methods were the only employment methods. American industrial capacity produced millions of bazookas, simple, inexpensive, relatively crude weapons that could be manufactured quickly and distributed widely. Quality versus quantity, precision versus mass production, engineering excellence versus industrial scale. Germany chose quality. America chose quantity. Both choices made sense within their respective strategic contexts, but quantity created opportunities for tactical experimentation. With millions of bazookas in the field, some soldiers inevitably tried unconventional employment methods. Most failed. Some succeeded. The successes got noticed, documented, and occasionally replicated. Over time, rare tactical innovations became occasional tactics, which became accepted techniques, which eventually became doctrine. The Tiger, that symbol of German armor superiority, died in small numbers to a weapon its designers had barely considered a threat, employed in ways training manuals said were impossible, by soldiers who succeeded largely through stubbornness and refusal to accept that their weapons were useless. So did one sergeant destroy 9 Tigers in one day using a stupid bazooka trick? Probably not, at least not in any way that historical records can verify. The number appears to be exaggeration, either deliberate mythology building or innocent conflation of multiple events and participants into a single dramatic narrative. Did sergeants like Charles Eastman develop and successfully employ high-angle bazooka tactics against German armor, including Tigers? Yes, absolutely, with multiple documented instances across various engagements in late 1944 and early 1945. Did this technique represent genuine tactical innovation that challenged engineering assumptions about tank invulnerability? Yes. The technique exploited a real vulnerability that existed because tank designers reasonably assumed infantry weapons would fire horizontally rather than in plunging trajectories. Did the technique change the war's outcome or represent a revolutionary advance in anti-tank warfare? No. The technique remained niche, difficult to execute, and dependent on circumstances that couldn't be reliably created. Most German armor died to conventional threats, other tanks, artillery, air attack, or mechanical failure. What the technique represented was something more subtle and more significant than revolutionary technology: human adaptability under pressure. When training and doctrine proved inadequate, soldiers improvised. When equipment seemed insufficient, they found unconventional employment methods. When the enemy appeared unstoppable, they looked for exploitable weaknesses. Sometimes they succeeded. Sometimes they failed and died trying. The successes got remembered and exaggerated in retelling until historical fact and military mythology blurred together into narratives like "one sergeant destroyed 9 Tigers in one day." The truth is more complex, more human, and ultimately more meaningful than the mythology. Soldiers like Eastman didn't accomplish impossible feats through superhuman abilities. They accomplished improbable things through ordinary human qualities: observation, creativity, determination, and willingness to try tactics that seemed stupid right up until they worked. On the morning of September 19, 1944, near Aricourt, France, Staff Sergeant Charles Eastman fired a bazooka rocket at a steep upward angle toward a Tiger tank 80 meters away. The rocket arced into the grey sky, reached its apex, and dropped onto the tank's engine deck. The shaped charge punched through thin top armor never designed to stop such weapons. The Tiger burned. Eastman fired again. Another Tiger burned. He fired a third time. A third Tiger burned. 3 Tigers destroyed in 3 minutes by a weapon that manuals said couldn't hurt them, using a technique that doctrine said was suicide, by a farm boy from Pennsylvania who'd learned trajectory by throwing rocks at crows. Not 9 Tigers. 3, verified, possibly more over the following weeks of fighting. The exaggeration doesn't diminish the achievement, it just contextualizes it within the messy reality of historical fact versus military legend. What matters isn't the precise number. What matters is that when Eastman raised that bazooka tube toward the sky instead of the horizon, he was doing something that looked stupid, that ignored conventional wisdom, that defied standard operating procedures. He was also solving a problem that conventional tactics couldn't solve, exploiting a vulnerability that engineers hadn't anticipated, and demonstrating that supposedly useless weapons become useful when employed creatively. The Tigers at Aricourt died because their armor couldn't protect against threats from above. They died because American industry produced enough bazookas that tactical experimentation became possible. They died because soldiers facing overwhelming enemy capabilities refused to accept that their weapons were inadequate and found ways to make inadequate weapons sufficient. That's not mythology. That's not an exaggeration. That's the fundamental reality of warfare. Innovation happens at the tactical level, often through methods that look stupid until they work, by people who refuse to accept that impossible means don't try. Eastman tried. The technique worked. Other soldiers learned from his example and tried similar tactics. Some succeeded. Many died trying. The war continued and eventually ended, with tactical innovations like high-angle bazooka fire contributing in small ways to the larger Allied victory. The burning Tigers at Aricourt III verified, perhaps more across subsequent engagements, stand as rusting evidence that impossible achievements become possible when soldiers refuse to accept the limitations that manuals, doctrine, and common sense impose. On that September morning, Eastman proved something that every military engineer should remember, and every tactical manual should acknowledge: the greatest vulnerability in any weapons system isn't technical. It's the failure to anticipate what desperate creative people will try when conventional methods fail. The Tigers burned because someone thought to look up instead of across, to shoot toward the sky instead of the horizon, to treat a direct fire weapon like an indirect fire mortar, because the tactical situation demanded trying something nobody else had tried. That stupidity, that willingness to attempt the improbable killed 3 Tigers and contributed to tactical lessons that influenced anti-tank warfare for decades. Sometimes stupid ideas work, usually they don't, but until someone tries, you can't know which is which. Eastman tried. The Tigers burned. And somewhere in the exaggeration of 3 kills into 9 lies a truth about warfare that transcends the specific numbers. Human creativity and desperation will always find ways to exploit even the best designed systems, because design assumptions eventually meet battlefield realities that designers never imagined. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.